Ciao friends and welcome to a new video from SQL BI. In this video, I want to go further in establishing the theoretical background that is needed in order to create visual calculations. I already introduced in a previous video visual shape. Visual shape is needed in order to create a hierarchical structure on top of the table, the virtual table, that visual calculation use for all of their calculations. In this video, I want to briefly introduce the new evaluation context, that is the visual context, and then the two main operators to move over the lattice that is created on top of the virtual table, expand and collapse. This is just a theoretical video, but it is much needed in order to create visual calculation that always work as intended. Let me show you this with a few examples. Let me start straight from the whiteboard this time. I have a matrix here, and I'm slicing by year, and then by country, by month, and finally by individual states. And the number I'm projecting there, that is not relevant at all. Might be a count of sales, or the sales amount, or whatever. What is important is that the matrix is showing data in a hierarchical way. However, we learned in the previous video that the table that is created by summarized column is actually a flat table. And this table undergoes the visual shape. With visual shape, you define the axis. Here we have the rows and the columns. And for each axis, you define the group by columns. The top level is the country, and then the second level is the state. And at the date level, we have the year, and then we have the month and the month number. Month number is needed for the sort order. Visual shape creates a hierarchical structure on top of the flat table. And this is strictly needed because if you carefully look at the matrix is showing, let's highlight them in green, values, which are the raw values, the values which are taken directly from the database while scanning the tables. But then summarized columns also adds a lot of totals and subtotals. We have subtotals here. We have an entire column of subtotals here. We have again subtotals here. And then at the last column is the raw total, and we also have the grand total. Actually, if you look at the matrix, most of the values are subtotals. This is not always the case, but at least it is in my example. Now, when you navigate through the virtual table, you need to do that taking into account the level at which you are looking at the number, because if you just look at the amount, or whatever column is here, this value has a meaning because it's specific for a state. This value, despite being in the same column, it is already a total. So at that level, I'm no longer looking at the month, I'm just looking at the total for 1 year for Alabama. In order to understand how the visual shape changes the structure of the virtual table, we can take a look at the lattice. Now, the lattice is a structure. It's a theoretical structure, but it is extremely useful in order to understand how things are moving inside a visual calculation. Because the lattice shows that you have the grand total. This is just the grand total. And at the grand total level, the only column that I can look at is the amount. There's no year, there's no country, there's no state. All these columns would evaluate to blank, and they are not accessible actually because they don't have any meaning. But then you have the subtotal at the country level, the subtotal at the year level, the subtotals at the country and year level. And you can look at the lattice showing all the different levels that you need to use in order to read the virtual table. The raw data is actually the one that is highlighted in orange, because this is the real data, the data that has been taken from the database. And then all the different levels, they are just nothing but subtotals. On top of the lattice, you can perform two important operations, because a visual calculation is executed at a specific level of the lattice. When you are here, you are showing some data for a given country. you have the current level. Now, the current level is, let's say, stored or pointed to by one new type of evaluation context, that is the visual context. You can think about the visual context as a selection of rows, like in this example, we might have Canada 2019-95, same as like a filter context or something like a row context, but it's a different context. The visual context filters a set of rows. Typically it is just one row, it might be multiple rows, but it is filtering multiple rows. But it also stores an important property, that is the level at which Canada makes sense. Because you can see Canada here, but you can also see Canada here. You can also see a row containing Canada here. All these are pointing to a row containing Canada, but they are at different levels. So the visual context should not be confused neither with the row context nor with the filter context. It's a different thing. The visual context filters some rows and it knows at which level of the lattice it is executing the calculation. The visual context is different and you need to think of it in a different way because it is neither a row context nor a filter context, and it's very easy to make confusion. Think about the visual context as a new type of evaluation context. On the visual context, you have operations that you can perform. The visual context filters the table. The visual context points at a specific row of the table, mixing both the row context and the filter context, but the visual context also knows where it is. And because it knows where it is, there are two operations that you can perform on the visual context. You can move up one level or you can move down one level. Let's say that you have the visual context that is pointing here, let's say it's in Canada. From here, you can move the visual context to the upper level, performing an operation that is known as collapse. Collapse moves up one level on one of the axes of the hierarchy, bringing you to a different level of the lattice. The opposite operation, let's do that in green, is expand. From the same context, you can go down and you perform another operation that is, let's write it here, expand. Expand goes down one level, showing more rows from the virtual table. Collapse goes up one level, showing a smaller number of rows. Collapse and expand are used a lot of times in visual calculations. When you begin writing visual calculation, you typically look at the templates and you will notice that expand and collapse are always present there. You can use both expand and collapse as a calculate modifier, so you can write calculate whatever expression you want and then expand or collapse and specify the axis that you want to use to move. You can also use them as scalar functions, so you just write collapse, sales amount, and then whatever number you want to see. Let me show you this with a demo. Instead of using this matrix, we use a different one. I lost my pen in the meantime. A simpler one that only contains the year, the sales amount. We only have one axis because this makes things a bit simpler. Let's say that I have the sales amount and I want to compute the sales amount at the parent level. So depending on where I am, which level of the visual context I am, I want to show the value at the parent level. That means collapsing, going up one level. So we can create a new calculation. Let's call it parent sales. And parent sales just uses calculate. Because we are operating on the visual context, we reference the sales amount, and then we use collapse. Collapse requires us to tell the axis we want to move. Collapse on rows. And if I hit enter, you now see that at the date level, I see the upper level, that is 168. And at the month level, I see the grand total level, that is 3 million. And at the year level, I get the grand total because that is the top level. You can write collapse this way. Where is it? I need to go here, parent sales, or you can also use the scalar version. You can write collapse, then you write sales amount, and you tell the axis you want to use. That is absolutely the same thing. Actually, collapse used as a scalar function in this way makes the code shorter, so you can put everything on a single line. This way, so the code is shorter, but it is actually the very same calculation. So collapse goes up one level. And it is useful to note that I'm referencing directly sales amount. I can grab the value of one column directly whenever I do collapse. This is important because performing the different operation that is expand will not allow me to access just one single column. But let's save this for later. You can write collapse sales amount rows and that is just fine. You can also use collapse, not on rows, but you can collapse the column. So you specified collapse. By default, collapse goes up to one level. You can write multiple collapse to go up multiple levels. I even thought this is quite unusual. Or you can collapse and provide specifically a column. So you can say collapse, and let's say that I want to go at the year level. Now, it's important to understand what is going to happen. When I do collapse and I specify a column, am I asking to go at that total level? Not actually. The semantics of collapse and expand when providing a column is slightly different. When you say collapse sales amount year, month, year, you are asking to go to the nearest level or to the lowest level that does not contain the year. Indeed, if I hit enter, you see that I get the grand total. Why is that? Let me show you that again with the whiteboard. When you write collapse, where is it? Sales, and you go at the year level, regardless of where you are, you might have the visual context pointing here, or pointing here. You're asking for the first level, the lowest level in the hierarchy that does not contain the year. And because the year is here, it is here, and it is here, the lowest level not containing the year is the grand total. So writing collapse does not reach the lowest level containing the year, but the lowest level that does not contain the year. You typically want to use collapse because you don't want to see a column. Collapse is the first function that moves. Collapse goes up. We have also another function that is expand. Expand works in a very similar way. However, you need to pay attention when using expand because when you use collapse, you always have one value. Again, let me show you this with the whiteboard. It's probably easier to understand. Let me just clear everything from here. Let's say that you have the visual context that is pointing here. You have Canada 2019 and you have the value for amount. When you perform collapse, collapse goes to the upper level and you always see a smaller number of rows. So you could look at the amount, you could look at the year, you could look at the country, and if you go up one level, you can still look at these values because you're not increasing the number of rows, you're always reducing the number of rows. So I can reference amount here and I can reference just amount here because I have one value here and I will have one value here. Here that value is the aggregate value. Here is the more detailed version of the value, but there will always be one. However, when you perform expand, things are different because when your visual context is pointing here, Canada 146, you can look at amount and you can grab the value of the amount. But what happens if you expand and go down one level? For the same Canada, you will have now Canada 2019, Canada 2020, Canada 2021, and so on. Multiple rows for the same Canada. Because you have multiple values for the amount, you can no longer grab the value directly. You always need to use an aggregator. Let me show you that with some code. Let's get rid of parentheses so we can just rewrite it. Let's say that I want to compute the sum of the children. I can write sum of children, and I use calculate, sales amount, and then I use expand on the rows. Expand goes one level down, and if I do that, I get an error. The error means that I tried to access one column, sales amount, but I can't because there will be multiple rows. That is why I need to use sum of sales amount. If I use sum of sales amount, I obtain the sum of the children, which in this case is the very same number. But for example, you can use it to compute the average of the children. You do the average of sales amount, and now this will no longer be the average, but the sum, but the average of children. And now you see that my visual calculation shows no longer the sum, it shows the average of the children. And the same that happened with expand, you can use, with collapse, you can use the calculate version, or you can use expand, average of sales amount, rows. Let me fight a bit with the editor. This is the scalar version. The result is absolutely identical. You obtain the same number. It's just that the syntax is a bit shorter. However, it is important to realize that what we are computing is using calculate to move the visual context from one level to another. Expand goes up, expand goes down, collapse always goes up. Finally, let me go back to the whiteboard. It is important to note that expand goes at the first level, so at the top level, that at the nearest level, that contains at the highest level actually, that contains the column. So you can also use expand, saying I want to expand at the month. You might have the visual context that points there, or that points here. If it points here or here in the orange box, expand will go to the highest level that contains the month. So from both levels, it will go directly there. If it happens that you execute expand and your visual context is already at a level where the column is visible, so if you execute expand from here, you will just not move anywhere because you are already at the level that is showing the column. Finally, it is important to note that expand and collapse, when used with a column name, they do not reach the same level. Because if you use a collapse at the year month, so you're using collapse at the year month, you will reach a level that does not contain the year month. If you use expand, again for the year month, you reach the first level that contains the column that you are specifying. So expand and collapse are operators that operate on the visual context, moving it to a specific level. They have their own semantics and they are extremely important to learn if you want to author visual calculations. So as you have seen, working with visual calculation requires you to understand the lattice. The lattice is vital in order to understand how a calculation happens. As I said in the introduction, you are probably likely to use the templates provided by Microsoft and start playing with them. But as soon as you write code by yourself, you always need to understand the lattice, because visual calculation happens in a visual context. The visual context points to a specific point inside the lattice. And the two operators, expand and collapse, let you move inside the lattice and perform the calculation at the granularity that you need. Expand and collapse are needed, for example, when you use calculate. They are needed when you want to perform a calculation on a specific granularity. They are quite always needed, and they can be used both as calculate operators or a scalar function. The choice is up to you. I typically prefer to use them as calculate operators because I read it a bit better, but really the choice is entirely up to you. Starting from the next videos, we will start to use all this theory in order to build more useful calculations. Enjoy DAX!